What is going on, everybody? Welcome to this video series. In this series, I'm going to teach you guys how to go from zero to hero, from scrub to somebody who's really good at programming. So a little bit about myself before we get started in this series. I am a software developer. I've been working professionally for a year, and I just graduated last May with a degree in software development, computer science to be exact, with a heavy focus on software development. I got hired at a Fortune 100 company, and I've been working there for a year now, really honing my craft, learning everything I can. And I thought, you know, I've done these series, like this in the past, and I really didn't have real world experience to base anything off of, because not only am I going to teach you how to code, but I'm going to teach you how it pertains to your job and stuff like that. I really wanted to wait until I had real world experience in the job field at a successful and large company to give you these tips and to start really making these videos. In this course, basically what I'm going to teach you is the fundamentals of programming. I'm not going to get extremely in depth. We're not going to be building like a API or full on web app or anything like that using crazy frameworks and just see, it's getting confusing already. So we're just gonna stop right there. It's gonna be super simple. We're using one language, no frameworks, and we're gonna build a few simple apps, and I'm gonna teach you how to kind of program, I guess. I mean, the absolute fundamentals of object-oriented programming, which if you're interested in going into college and into school for computer science, that's what you're gonna be taught for the most part. So this should give you a really good baseline for going into school. You should be ahead of the curve. Without further ado, let's get started. Today we are going to be talking about the very first thing you need to know in programming, and that is an algorithm. It's the basis of every single program, and even though today when I go to write a program, I don't technically write out this algorithm, actually write it out on a piece of paper, in the back of my mind, this is the way I'm thinking. So programming is very logical. When you actually go in and write the code, it has to be written in a specific way for it to compile and work. But the actual idea behind coding is very logical. The way these programs run, the way you design them and build them up is very logical. And an algorithm helps you plan that logic. So for a real world example, think of a cake recipe. A cake recipe has step-by-step instructions on how to make a cake. Well, an algorithm is going to have step-by-step instructions on how to write this program. At the end of the day, no matter what oven, no matter what measuring tools, what spoons, whatever you use as a chef, or as a baker rather, to make this cake, as long as you follow the algorithm, or as long as you follow the recipe, your cake is going to be the same as the other guy's cake, no matter what tools he's using. So an algorithm is a way to generalize a problem, to break down a problem into steps that a developer can use to then write a program, no matter what programming language they use. Just like a recipe can be used by any baker, an algorithm can be used by any developer. It's a way to write out the steps of your program, the way it works step by step. Any programmer, no matter what language, what framework, what device you're coding for, can look at this algorithm and they can write a program for it. So it's a very good way to start thinking logically like a programmer without actually writing any code. So if you can't write an algorithm for your problem, you're not going to be able to code it either, because even if you know the syntax and the way to actually write code, logically, you need to have that mindset to allow you to build out these programs. So that's what we're going to start with today. It's going to be super simple, super simple, like 2 + 2, literally that simple. But we're going to check out how you actually do this and how you actually accomplish this. All right, so now that we have a general idea of what an algorithm is in like the simplest form, the simplest terms, let's open up a Word document here, and we're actually going to write one for a simple problem. So let's just get rid of that real quick here. Okay, so back on topic. Sorry about that. Let's say we have two numbers, right? I actually scratch that. Let's say somebody using our program has two numbers and they want any two numbers in their mind, any two numbers floating around in that brain of theirs, and they want to add those two together to get one number, also known as the sum of the numbers. What would be the steps to add those numbers together? So let's say they had 3 and 7 in their head. They want to add those together to get 10. So pause the video and write out, literally write out, I want you to write out step by step how they do that. How do they get two numbers and create one? What are the actual steps of doing this? So go ahead. Most likely you guys probably wrote something like take 3 and add to 7, right? Something like that. Or maybe you're getting closer to what we want and you wrote something like that. You're still a little bit far off. You're getting closer, but you're a little far off. So with algorithms, there's a certain way that we do things, and that's gonna introduce variables to you guys. So this is your first programming term. Get ready for it. Ooh, maybe if I can write variables. So variables in programming, basically, let's try to simplify this. Okay, so let's take a regular folder on your computer. Here's First Day Back. It's a folder called First Day Back, but what does it actually represent? Well, when you open it, it has all these clips in it. This is from a skateboarding video I made like a year ago. A variable in programming is basically, I don't want to get too far into it right now because we'll get more into it when we actually start coding in the next video. But it's basically a way for you to store values that you're interested in, that the program's interested in, that the client using the program is interested in. It's a way to store them and name them, so later on when your program continues to run, you can get those values again and use them. For example, let's say we have two numbers in our problem, right? We have the first number and we have the second number, and we want to add those two together. So let's say number 1, we can just name it number 1. So literally number 1. Now, why does it look so weird? Why would I write it like that? Why wouldn't I just write it number 1, or maybe even, capitalize the N, number 1? Why do I write it like this? Now it doesn't have to be like this. There can't be a space in it, keep that in mind. There cannot be a space in variable names, but it doesn't have to be capitalized like this. You could do this, you could do this, you could do all caps. You don't really want to do all caps, but you could. It's not going to break your compiler, but basically it's just a way, it's just a syntax, it's for readability, it's just a way, it's just the way we do things. And if you don't do it the way we do it, just get out, just go, you're done. I'm completely kidding. There's many ways to name variables. This is how I'm going to be doing it throughout the series, and this is how most programmers will do it. It's called camel case, and you start with a lowercase. You don't always have to start with the lowercase, but usually I do if it's a variable. Back on topic, this name here is actually going to represent a number that we're interested in, that the user sends into the program to get added to the other number. So you can think of this as a folder, if you will. So think of it as a folder, and inside that folder is the number 5, or whatever number we want to use. We have number 1. What else are we going to need in this program? We're going to need another variable called number 2. What else are we going to need in this program? Well, we want to add those two together, right? Now, we could just add them and output that addition value, but to keep things simpler and to keep things standardized across the board, we are going to have another and final variable called result. So there's 3 variables there. So when you guys said, how do you add two numbers together? Take 3 and add to 7. Okay, so that's probably what you came up with, something like that. Let's change this to now use our variables, and now we're getting closer to what an algorithm is actually going to look like. So take number 1 and add to number 2, right? So that's looking a little bit better. Another thing I forgot to mention about algorithms is they are a standardized solution for an endless amount of problems. That's something that's very important, and I should have put that in, but here we are a couple minutes later, and I'm telling you now, an algorithm is a plan that can solve many different problems. So you don't want to design one that's super specific. And what I mean by that is you don't want to design one that only can add 3 and 7 or only can add 5 and 2. You don't want that at all. You want something that can solve any time somebody wants to input 2 numbers, add them together and get the result. You want your algorithm to be able to handle that, right? That's the beauty of programming. You design something that can handle an endless amount of problems problem sets, I should say. So if we were to just say take number 3 or 4 or whatever we want to do and add to 7, we could write a program that does that. It would be very easy, but what's the use? You know, a user can't input their own numbers. Yeah, we solved the problem of 3 and 7, but if the user changes their mind and they're like, oh, I want to write 4 plus 4, then we have to write a whole new program for that, and that's just unreasonable. So we want to write one program that takes care of all of this. So that's why we're going to be using these variables. And add to number 2. So that's looking a little bit better, I guess, but it's still not in the form that we want it to be in. So let's actually write out a real algorithm. Let's actually write what is going to happen. And you guys weren't able to write this at the beginning, and that's perfectly okay, but I'm gonna break this down step by step with what actually has to happen for this program to work. So step number 1, and each step, each line in an algorithm is going to be a new step. So keep that in mind as well. So our user is going to physically type in 2 numbers to this program, and we're gonna add them together, and it's going to show them what the sum is, right? So what's the very first thing that's going to happen? Our program's not going to take in a number already. The user is going to type on the computer, and this is important. So user enters first number, right? Because it's not like the program boots up and boom, a number's already waiting for it. The user has to type something in, and that's important because when you go to actually code it, if you don't have this part here, user enters first number. If you just started with take number 1, right? If you just start with that second line, a programmer is not, a developer is not going to know what to do with that. I don't know what to do with that. Where does number 1 come from? Is it coming from a file? Is it coming from a database? Is it coming from a different method? Is it coming from a different class? You guys don't know what these terms are, but that's what's going through my head when I see that. I have no idea, where does that come from? So having that user enters first number is important because now I know as a developer, okay, they're typing a number on the keyboard and it's gonna be submitted into my code, right? So user enters first number. We're gonna set that their input to number 1. And there's our variable that we came up with a couple minutes ago. So we're setting the input. Whatever they type in is going to be stored as number 1 in our program. So think of it again, they type the number, you hit enter, that number goes into the folder called number 1. Okay, simple. So what next? How about we just copy and paste? So a little skill that us programmers, us developers like to use a lot. Copy and paste. User enters first number. Oh. Second number. There we go. And we're going to store that as number 2. Okay, we're getting somewhere, right? So now we have our 2 numbers, right? We have number 1, we have number 2. You might just say add 2 numbers and you're done, right? Or you could say add number 1, add number 2. It would work. It would work. You could do add 2 numbers, show user. Or, it would be better to keep this on the same line and say and show user, right? That would work, and you can do that in your program if you choose to. But what we're gonna do is we're gonna create the third variable result, like I said, and what we're gonna do is set sum of number 1 and number 2 to results. Okay, so there we have our third and final variable in this mini program we came up with. And then finally, we can say show. All right, so there it is. Now, a better way to say show user is to just say output, because we want to think of this as input and output. Now I want to break this down and make it more syntactically understandable to a developer. I mean, as a developer, if I look at this, I know exactly what's going to happen. I could write this in probably 30 seconds. But if there was a huge algorithm that I was given, which never happens so far in my job, I haven't been given a 10-page long algorithm and told, okay, go make this. If I sat down and I wanted to plan out how a small chunk of code was going to work in my program that I'm working on, and I wanted to make an algorithm for it, I wouldn't type it like this. So what I would actually do is, don't have to read as much, I can just quickly see the patterns that my code is going to need. So basically, we'll just get rid of this, and we'll get rid of this too. We'll get rid of all this. And there it is. That looks a lot better. This is logically a lot better than what we had before, where it was just take 3, add it to 7, right? This logically makes more sense, and it's a very simple problem, but we broke it down and made a program and steps to a program that make this problem, it makes you realize that any problem, small, large, has a ton of steps to it. You know, you can break it down and break it down and break it down, and you have to, as a programmer, to be able to write the code. So hopefully this video gives you what you needed to know, what you were looking for on algorithms. If you have any more questions, please leave comments down below. I will try to answer them all. But I wanted to make this to get you guys in the right mindset. How does a programmer, how does a developer attack problems? What do we do differently than somebody else? You know, somebody that doesn't code. How do we think of these things? And it starts with a very, very basic understanding of how algorithms work and how you build and convert a problem into an algorithm that can then be coded, right? Because that's the workflow of this whole thing. A client brings you a problem, you have to determine how to break that problem into a way that you can realistically code, and then you code it. And there's a lot of back and forth between you and a client. You got to figure out, you know, do you want this feature, blah, 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 blah. And you work, you make a design, you do a lot of this stuff. Maybe you don't actually explicitly write these algorithms, but you're thinking of them, and then you can start coding and start working on your project. So this is step number 1. If you don't understand how to break down a problem into simple steps like this, you're going to struggle with programming a lot, because it's the same type of logic. So hopefully this was simple enough for you guys to understand. Again, if you have questions, leave them down below. And in episode 2, we will code a simple algorithm, and you'll write your own program, your first program. You're gonna be able to hit enter, that bad boy's gonna run. You're gonna be able to input some numbers, you're gonna add them together, it's gonna boom, print out the sum, and you're gonna be a happy camper. So thank you guys for watching. Subscribe for more videos, they will be coming out. I'll see you in the next one. Peace.